Hi everybody, this is the optimization, this is Math 31 optimization review. This is question 2. And this question here is really just a classic problem from Math 20, but we're going to do a little, apply a little calculus twist to it. One number plus the square of another total 27. Okay, so I just got to identify some variables here. So we're going to let x equal the first number, okay, and we'll let y, we'll let y equal the second. Honestly, that's about the best we can do to start off with here. When we're supposed to find the numbers so that their product is a maximum. Okay, well, I'm not telling you what that product is. All I'm telling you is that I want that product to be a maximum. So we're going to just introduce a p-value here. We're going to call this their product. And because this is the thing that I want to maximize, okay, because this is what I want to maximize, this is the thing that I'm going to complete the square on. Sorry, not complete the square. So I really am in the Math 20 mode here. This is the thing we're going to take the derivative of. Okay? So the first equation that we're going to get here is one number plus the square of the other is equal to 27. Okay? Well, there's a nice straightforward relationship between x and y here. Now, p, the thing that we're going to try to take the derivative of here is going to be simply xy. Now, with under the assumption here that y is a function of x, I could take the derivative of this and with the product rule and set them equal to 0. But really, what I want to do here, if I'm going to be able to solve something here, what I want to do is I want to take this equation and plug it into this one. So the very first thing that I'm going to do here is take this perhaps and isolate for the y. So that's going to equal 27 minus y squared. Now, I know a lot of people are going to hate the fact that I'm isolating for the x when I should be isolating for the y, but it's just because I'm super lazy here and I don't want to end up having to take the square root. And it doesn't matter. Okay, we'll just take the derivative exactly the same way we would have otherwise. So now p, make sure you can see this here, p is going to equal x times y, but this, it is the x that I got rid of. So x times y, in which case this will be 27 minus y squared times y, which means p will equal 27y minus y cubed. Okay? Now, I'm going to take the derivative of this. But now, because y is the variable here, I will simply take the derivative with respect to y. So I'm just going to basically pretend that y is the x. I'm not going to take the derivative implicitly. I'm taking it as if y is just x. So this will become 27 minus 3y squared. Okay? Now, to determine where this is a maximum, what I need to do here is set the derivative equal to 0, because we know at the maximum or the minimum, we know that in a polynomial function that'll become, the slope will become 0. What I might do here is divide both sides by 3, just to make this easier. So 9 minus y squared is equal to 0. And now we're going to get 3 minus y, 3 plus y equals 0. So we're going to get two different values here, plus or minus 3. Can't see that. There you go. Okay, so now I want to find the number so that their product is a maximum. So what I'm going to do here is I'm going to take a look at my derivative. I'm going to take a look at my derivative function here, which really factored down to this. I'm going to write those values out here. Here's negative 3, here's positive 4. Why would I have done that? I have no idea. Positive 3. And what we're going to do here is we're going to take a quick look and just think what's going on here. Now, this is a parabola. Okay, if you go back up to here, you take a look at your derivative. This is a parabola that opens, this right here is the parabola. This is a parabola that opens down, okay? Because there's a negative in front of the square term or the quadratic term. So this is going to look like this right here, which means it's going to be negative here, positive here, negative here. And if you interpret that in terms of calculus, we know that this is decreasing, increasing, decreasing. And so if you decrease and then increase, we know that this point is going to be a min. if we increase and then decrease, we know that this point is going to end up being a maximum. So it's the positive 3 is the one that we're interested in. So therefore we can conclude, okay, that in order to get a maximum, y must equal positive 3. And so x, and we come way back over here, okay, if x has got to equal 27 minus y squared, okay, that's going to be 27 minus 3 squared, which is 9. So 27 minus 9 is 18. So the two numbers that we're looking for here, okay, are 18 and 3.